So, the 2018 examiner's report. The examiner's report is where they give you the answers. So here are all the answers to the questions. It also tells you what percent got them correct. So question 1, 85% of the cohort got that correct, 7% picked D instead. If we have a look down here, it says most questions were accessible, but there were a couple where key skills and key knowledge from the study design were students found that challenging, namely questions 20, 22 and 23. So if we have a look at question 20, correct answer was B. It was highlighted, 39% got that, 28% picked D. So there was obviously a reason why D was an obvious wrong choice. Question 22, 29% picked the correct answer of E, 41% picked D. Okay, I did it the other day with Emma and I picked D as well because I made the same mistake, the common mistake, which we're going to look at in a moment. And question 23, 29% got the correct answer A, and C was a more common incorrect answer. So just have to be aware of that. Some of the incorrect answers are the answer you get if you make a basic mistake. So just because the answer's there doesn't mean it's right. Now, the whole key to the practice exams is you're building the skill of doing the exams. So this is the first one you've done. Okay, there's going to be some stuff in here that you would have found challenging. Hopefully there's stuff in here you would learn from, so that when you do the second practice exam, you're going to go much better at it. And by the time you get to the actual exam, you'll be much better again. Okay, so let's look at some of the questions, and what I'm going to look at is some of the more challenging questions. So I'm not going to go through every single question, but what I would suggest to you is you get the examiner's report and you read through it with your exam side by side. Okay, so first of all, we're going to look at question 8. So question 8, only 46%, so we're only looking at the questions that less than half of the cohort got correct. So 46% got question 8, 25% said B, 16% said A, is fairly evenly mixed. There is an obvious trick here. So this part up here is the examiner's report. So this is from the examiner's report. This is the question that was seen. So the question said we were given this data and we had to say what the least squares, what this line, the equation of this line is. So down here is a resting pulse rate, down here is the time spent exercising. Now the trick here is that most people are looking at the y-intercept and saying 67.2, so eliminating answers C and D. And then it's going down, so it's going to be minus, and if we see it goes right through that point, then it goes down next to the next point, so it's going down by more than 1, so it's going to be minus the 1.1. So most people said answer D, so most people said answer B because of that. Now the problem here is that's a 1 on the axis down here. That's just the number 1. The y-intercept is at 0. So the y-intercept is going to be even higher than 67.2, presumably 68.3. That's the trick. Okay, the y-intercept is when the x value is 0, not 1. So just be careful of tricks like that. So the correct answer here was D. Okay, so the correct answer here was D, and that's because the y-intercept 68.3. Now just have a look about this. So see here, it goes right through that point, if not slightly above it. Here it goes slightly below, so it's dropping more than 1. Okay, so it's dropping more than 1. So we're going to assume it's dropping by 1.1. Dropping by 1.1. Okay, but we can see it is dropping by more than 1 because there's a little gap just in here. Okay, so that's question 8. I'm not going to read through that. You're welcome to read through that at your own leisure. You can pause the video later on if you watch it back. So question 9. Question 9. The coefficient of determination is 0.8339. So the correlation coefficient R is closest to. So this one is R squared. So R is the square root of 0.8339, and you get your scientific calculator and go the square root of 0.8339, and you get 0.913. Fine, that's fine. So most people look at that and say, okay, that's E. But it's relating to this graph, which is a decreasing graph. Okay, so the correlation has to be negative because it's decreasing. Okay, so the correct answer is A, negative 0.913, just because of the direction of the data. So many students incorrectly took the positive square root value and chose option E. The scatter plot on the examination showed the direction of the association was negative, so we've got to have negative 0.913. So once again, both of those questions, they had less than 50% of the state got them correct, because there's little tricks in them that you've got to watch out for. Okay, and they're the little tricks that you're going to get better and better at the more practice exams you do. Okay, the more times you're exposed to that. Okay, question 13. So this is the question, that's the examiner's comments. So this is the question. The statistic analysis of a set of bivariate data involving variables x and y resulted in the following information. So we've got the mean, we've got the mean of the x, mean of the y, standard deviation x, standard deviation of y, and we've got this equation which is given to us. Okay, now people are struggling on this a little bit because it's only a very obscure bit of the course, but we've got this formula on page 132 of our text that we can, y equals a plus bx, b is equal to r times sy over sx, and a is y bar minus b times x bar. Okay, so just be aware that makes sure you've got that information from page 132 in your bound reference. Okay, it needs to be in your bound reference so you can refer to it. I've seen it in a couple of places now. I think it's on one of the other practice exams you're going to do as well. So the slope of the line B, okay, so we've been using information to find we want to find R. Now R is in this calculation, the slope of the line B. So we've got B is 1.31 equals R times SY is 3.24 and SX is 2.33. And we've just got to solve that. So we're going to multiply the 2.33 up there. We're going to divide by 3.24 and we get R equals 0.94, which is option D. Okay. So once again, it's been recorded. You can come back and look at this later on if you want. So the next question, question 14. A least squares line is fitted to a set of bivariate data. Another least squares line is fitted with response variables and explanatory variables reversed. Okay, so we're going to swap the x and the y around. Which one of the statistics will not change in value? Okay, now the residual values are actual minus predicted, and they run up that way. So they're the difference in the y value. So if we swap the x and the y, they're going to change. So it's not that. The predicted values, well, we've been predicting y's, now we're going to predict x's, so that's going to change, so it's not that. The correlation coefficient though, the correlation coefficient is just the correlation between the two variables, x and y. We're still using the same data, we've just switched the x and the y, so that one is not going to change. So C looks like it's the answer. The slope's going to change because we'll switch the x and the y, and the intercept's going to change because we'll flip the x and the y. So the answer here is C. So it's just testing that you've got a knowledge of how a regression line works. Okay, it's an obscure question. You haven't been asked that question like that in the chapters or anything like that. It is testing that. They will throw in questions like that will just test your understanding of how things work. Okay, so just be aware of that sort of thing. Okay, now as I say, I'm just going over the really difficult questions here. At the end, I'm going to give you an opportunity to ask me if there's any other particular questions you'd like me to cover when we get through these. Okay, so here the graph, this is the question, this is the examiner's report. The graph below shows a value, so we've gone to financial maths, a VN of an asset as it depreciates over a period of 5 months. Okay, now I've actually added to the graph, which I'll explain in a minute. Which one of the following depreciation situations does the graph best represent? Okay, those three are going down in a straight line. Which is a flat rate. Those three are going down in a straight line, which is also a flat rate. So we've got flat rate depreciation here. Okay, if it was reducing balance, it would go down and it would be curved. Okay, so we've got flat rate depreciation with a straight line. So we can get rid of the bottom three. So our options are flat rate depreciation with a decrease in depreciation rate after 2 months, or flat rate depreciation with an increase in depreciation rate. So depreciation rate is how quickly it depreciates. So because it's depreciating more, that's an increase in the rate of depreciation. Okay, it's slowly depreciating, and it's much more quickly depreciating. So we're increasing the depreciation rate. So that's going to be answer B. We're increasing the depreciation rate. Okay. Now, question 22. Questions down here. It's a really small print, sorry about that, but you guys should be able to read it. Adam has a home loan with a present value of that amount of money, 175. So it's going to be that's his present value. The interest rate for Adam's loan is 3.72% per annum, compounding monthly, and his monthly repayment is $3,200. The loan is to be fully repaid after 5 years. Adam knows the loan cannot be exactly repaid with 60 payments of $3,200, so this is the last payment. It's going to be an adjustment. To solve the problem, Adam will make 59 payments of $3,200. He will then adjust the value of the final repayment, so the loan is fully repaid with the 60th repayment. Now we just have to calculate the value of the 60th repayment. This looks like a really straightforward question. This is just a classic financial solver question, but most people will put n, and I did the same, n equals 59. Okay, and if you put n equals 59, then it's going to tell you how much, what the future value will tell you how much is still outstanding, but you actually have to pay that future value plus the interest for that month, that final month. Okay, so the calculation gets quite complicated, so don't use n equals 59. We want n equals 60. So we're going to put in n equals 60. The interest rate is going to be 3.72%. The future value is what's written down there on the page. The payments are negative 3,200. He's paying it off. And the PY and CY are 12 because it's compounding monthly. That's reasonably straightforward. When we do that, we want to work out the future value. So we want to work out what the state of the loan is after 60 repayments, so after the end, at the end of 5 years. And we do that and we get that the future value is negative $368.12. That means he still owes that much money. Because it's negative, if it was positive, that would mean he would overpay it. So he still owes, at the end of 60 payments, he still owes $368.12. So his final repayment has to be $3,200 plus $368.12, which is going to be $3,568.12, which is answer D. Okay, so it's not a hard question, but there is a trap there. A trap in, if you put n equals 59, and the thing is, if you put in n equals 59, you'll find out that he still has to pay $3,557.09, but he has to pay that plus the interest, okay, and the interest is going to be work out to be something like $9, okay, so it's easier to do it with just using n equals 60. Okay. Question 23. Okay. 5 lines in an amortization table for reducing balance loan with monthly repayments. So these are months going down here. And when you're doing an exam, just highlight keywords. It's really important. When you're doing an exam, highlight keywords. It's good to have a highlighter in the exam. If you haven't, just circle them with a pen. The interest rate for this loan changed immediately before repayment 28. Okay, so here they've made a change to the interest rate. So what we need to do is we need to work out what the interest rate is. So we're going to do 967.08 divided by 230,256.78. Okay, so we're going this number divided by this number. So the interest paid, this interest is paid on the balance of the loan at the end of the previous year. So this number divided by this number, and that gives us 0.42% per month. So down here, we're going to now work out, we can either do this one divided by this one, or we can do this interest divided by this one. And so I'm going to say 996.99 divided by 226,588.02. You'll see up here they've done this combination. Doesn't matter, it'll be the same thing. And that's going to be, just remember when we do these, we times by 100 to make it a percent. That's going to be 0.44% per month. Okay, so the monthly percentage has increased by 0.02% per month. But the answers are all per annum. So we're going to have to times this by 12 to get 0.24% per annum. So the answer, the correct answer is A. Okay, so we're working out the monthly, the interest relating to the balance at the end of the previous year. That will give us the monthly interest. Same here, the interest divided by the balance at the end of the previous year, the monthly interest. So it's increased by from 0.42 to 0.44% per month, so by 0.02% per month. Times that by 12 to get 0.24% per annum. Okay, once again, slightly off. It's really testing you've got an understanding of amortization tables or how loans work. Okay, so it's an obscure type question. That's why you need to do practice exams to come across these types of questions. Okay, so now we're just going to have a look at a couple of questions from the matrices module. Questions that student found most challenging were question 5, question 7 and question 8. Okay, so 42%, 28% and 46%. Question 7 being the really hard one. Okay, and look at how evenly spread the answers are for question 7. So let's have a look at it. First of all, we've got question 5. So question 5 got all this information about Liam's physical activities. Okay, so he cycles C kilometres, he runs R kilometres, he swims S kilometres and he walks W kilometres per month. Okay, and that's what we want to work out, how far they are. So the number of so this table tells us the number of times in a month that he did each activity for month 1 for each individual month, and this tells us the total distance for all activities he's covered for the month. So we're going to say the number of times times the distance for each month gives us these total distances. So we've got basically a set of simultaneous equations. Okay, we need to find this one. So what we're going to do, if we call this, we call it A, C equals B. Call it D for distance. AC equals D. So if we've got AC equals D, it's good to just do this working out over the side, just with the letters and without the full matrices. Okay, so they're showing you in the examiner's report how to solve it, but the best way to do it, we're just going to say this matrix A times C, which is the unknown matrix, equals D, the distance matrix, and we want to find what C equals. Okay, so we need to get rid of the A, so we're going to go A to the minus 1 A, C equals A to the minus 1 D. They cancel out, so we get C equals A to the minus 1 D. If you do that just on the side, now all you need to do is put your A and your D matrices into your CAS calculator. So your A matrix is that big 4x4, your D matrix is this 4x1, and you'll end up with a 4x1. So if you put that into your CAS calculator, we're going A to the power of -1 times D. Okay, and we get 8619, and 8619 is option B. Okay, so each time he cycles, on average he cycles 8 kilometres, he runs 6 kilometres, he swims 1 kilometre and he walks 9 kilometres. Okay, so but this is the key to it, just writing down, just giving the matrices letters. Okay, it's not going to get you any points for the examiners, it's just going to help you with your head. So question 7, there's a lot of information in the matrices questions, so they're a bit small. The writing's a bit small. So question 7, the study of an antelope population in a wildlife park shown that they regularly move between the east, north and the west locations. Okay, so we have this recurrent matrix recurrence rule that the number of antelopes in each location in the next month is equal to the transition matrix times the number of antelopes in each location this month minus D. Okay, so we're given the transition matrix, we're given D, so we've got that information. The state matrix below shows the population of the antelope tree. So this is A3. If you can't read it, that's actually A3. And what we've been asked to do is we've been asked to find A2. So this is once again just a twist on what you've been doing. So let's have a look up here and just do the calculations. A3 equals T times A2 minus D. So this is similar to what we did last time. We're just going to do it with the letters. A3 equals T times A2 minus D. We need to find what A2 is. We know what A3 is. We know what T is. We know what D is. You can put them all into your CAS. So now we've got to go A3 plus D equals T times A2. We're just plussing D over the other side. So T times A2 equals A3 plus D. So what we're doing, we're just going to add these two matrices together to get A3 plus D. And to get A2 on its own, we've got to go here, T to the minus 1 times. So we've got to do the same here, T to the minus 1 times this whole thing. So A2 equals T to the minus 1 times A3 plus D. Okay, so we have a look at the examiner's report. They've done similar over here. They've worked out what TA2 is. They've done the A3 plus D. So T to the minus 1 times that. You could have T, A3 and D in your calculator. You could do it like I've got it with the brackets. You'd need the brackets though, make sure, because we've got to add them together first. And if we do that, we should get 1630, 2800, 2270. And the question asks the number of antelope. So antelope in the west location, and that's the third one, which is the 2270, which is answer E. Okay. The key is just to do this working first, this algebra. Do the algebra first, then you just put into your CAS. Once you've got this step, you just put straight in your CAS, T to the power of minus 1, we've got a multiplication sign, bracket, A3 plus D. Go back, try it later on, and you'll see it works. And I think this is our last question we're going to look at. Question 8. A public library organised 500, so there's a key here that's, a concept here that's a bit interesting. 500 members into categories according to the number of books each. So we've got J, K, L, M and N, they're the categories. Okay, doesn't really matter what they are. We've got the transition matrix, shows how the number of books borrowed per month by the members is expected to change from month to month. Okay, so 10% who borrow J, no books 1 month, are going to continue to borrow no books. 20% who borrowed 1 book next month will borrow no books, etc. Okay, so that's our transition matrix. You don't need to understand any of this really, because all it's asking for is, in the long term, which category will have approximately 96 members each month. So all we have to do is go T to the power of, well, they've picked 50, you could pick 100. T to the power of 100 equals T to the power of 100 times S0, and that gives us our long term. But what is S0? They haven't given you S0. All they've told you is that there's 500 members. So what you need to do is you need to make up an S0. Okay? As long as your S0 adds to 500, it doesn't matter. So you could use anything, because long term it's all going to go to the same value long term if you go long enough. But because there's 500 and there's 5 categories, we're just going to use 100 each. But it doesn't matter. You could pick any numbers you wanted for them, the initial state matrix, as long as these numbers add to 500. Okay, that is the key. Numbers have to add to 500. So we just go T to the power of 100 times S0, and that will give us something that looks like this. And we'll see that 96 is the value, so 96 is going to be option K, which is answer B. Okay, I'm going to keep it recording. If anyone's got any questions, you can put your hand up, you can put something in the chat. If there's any particular questions you would like me to look at, you can tell me. I'm looking at the chat right now. You can turn your microphone on and ask me. The opportunity to ask a question, going, and it's not gone because it won't go. I'm going to stop the video recording though.